Bismillahirrahmanirrahim. Greetings. In the opening of the previous lecture, I mentioned that quite many college students taking freshman, sophomore courses in mathematics have difficulties with the concept of absolute value. Now, I would like to also add that the students also have much difficulty with the concept of principal square root and the definition of a square root of x squared to be equal to absolute value of x. Now, most of the textbooks, they write a square root of x squared equals to absolute value of x by definition. But they do not explain or indicate the motive behind that definition. Now, the contents of this video lecture is going to be kind of introductory, give us some muscles, give us some preparation so that we can fully comprehend the reason that a square root of x squared is defined to be absolute value of x. Why a square root of x squared is not equal to x. So let's get started, shall we? Now I have written here this one, a square root of x equal to x, and I'm saying y is not equal to x. That's what we think a student do ask. And why is it defined to be as absolute value of x? So we start with very fundamental from the background that we need. Again, I repeat myself, this video is going to be introductory, give us enough background knowledge so that we can comprehend the reason behind the reason that the square root of x is defined as to be absolute value of x. Okay, we start with from elementary grade school mathematics, and that is 2 plus 2 plus 2, I wrote how many of them? 3 of them. 2 plus 2 plus 2 equals to what? We write one of the term, which is 2, multiplied by the number of terms, which is 3. So 2 plus 2 plus 2 is 3 times 2. And multiplication is to what? To simplify addition. Now, this is the notation we invented to represent what? To represent repeated addition. Now, in a very similar manner, 2 times 2, we cannot write a 3 in front of it because that will violate this previously accepted or adapted or defined notation for multiplication. So in order not to confuse with that, we write the 3 on the top of 2. So 2 to the 3 means 2 times 2 times 2. And that will be, then what else we notice from that, we write 2 times 2 times 2 5 times. One, I wrote it in parentheses, 3, 2 times 2 times 2, 2 to the 3 times 2 times 2, which is 2 to the 2. And we notice that 2 to the 3 times 2 to the 2 is same as 2 to the 5. And that indicates that the powers are going to be added. So we generalize this idea and we come back to the formula that we have seen it so many places from grade school up all the way to the end of our endeavor for the mathematics. And that is the way. Now, a to the m times a to the n equals to a to the m plus n. Now, these m and n, most of the time, especially beginning, we consider them as an integer. Now, I haven't talked about m and m to be negative. I'm going to go over that. But later on, the m and n can also be rational numbers. But the proof of that is way behind the concept of this freshman, sophomore level. It's a little bit upper level, the proof of that. But anyhow, Now, going back of that and see m and n can also be negative numbers and how we can come to that kind of agreement and definition. Now here, we know let's a to be 2 times 2 times 2. And b, as I have written, to be 1/2 times 1/2 times 1/2. Then a times b will be what? Will be 8 times 1/8, which is what? Which is 1. They are kind of multiplicative inverse of one another. Now, we also notice that 2 times 2 times 2 is 2 to the 3. So we say, okay, if we have something that is 2 to the negative 3, then 3 plus negative 3 is 0, and 2 to the 0 equals to 1. Any number except 0 to the power of 0 equals to 1. The proof of that is very elementary. You can check it in internet, and I encourage you to do that. The justification of that. Any non-zero number to the power of 0 equals to 1. So that motivate us to define 1 over 2 as 2 to the power of negative 1. Because it will satisfy this general form a to the n times a to the n equals a to the n plus m. You see how nicely, fantastically they are built up, one after the other, that has reached us for so fascinating for today. Okay, now we go to another observation. And also, excuse me, I did forget to mention, let me mention that one, and that is 2 to the 1/2 is 2 to the 1 to the negative 1. So we get 1/2 times 1/2 times 1/2, we get 2 to the negative 1 times 2 to the negative 1 times 2 to the negative 1. Then we can apply this rule, which means what? Which is 2 to the negative 3. Then 2 to the 3 times 2 to the negative 3 is 2 to the 3 plus negative 3, which is 2 to the 0, and 2 to the 0 equals to 1. So they are multiplicative inverse. You can see that 2 to the 3 and 2 to the negative 3 are multiplicative inverse of one another. Now, let's see about this one and see what this may motivate, what motivation this may bring to us. We know that 2 to the 3, 2 to the 2 to the power of 3. Let's see what it is. 2 to the power of 2 is 4, 2 times 2. We already mentioned that. Then 4 to the power of 3 equals to 4 times 4 times 4, which is 64. And then, same if we write 2 to the 3, which is 8, to the power of 2, which means we are changing these two, we end up with 8 squared, which is also 64. Is that right? So we come from this observation, we come to this generalization that a to the m to the n equals to a to the m times n, not plus. A to the m to the power of n is a to the m times n. All right? Now, since multiplication has a property of commutativity, we say multiplication is commutative, so m times n is same as n times m. So we can, in another word, exchange these two. Do you follow me so far? Now, we come to this idea. We say, okay, we know what 2 to the 3 means. 2 times 2 times 2. We know 2 to the 5 means. Huh? Now, how are we going to interpret 2 to the irrational number which is not integer? For instance, what is 2 to the 1/2? What is 2 to the 1/3? What is 2 to the 2/3? Rational numbers that they are not integers. How are we going to interpret that one? Now, look at this one. 2 to the 1/2 times 2 to the 1/2 is what? Is to the half plus half, which is 1. So 2 to the 1/2 times 2 to the 1/2 is 2 to the 1/2 square. Is that right? 2 to the 1/2 square. Now, from what we learned from generalization, a to the m to the n is a to the m times n, so we end up with half times 2. And what is half times 2 is 1, so 2 to the 1/2 square is what? Is equal to 2. So what does that tell us? That tells us that 2 to the 1/2 is a number. It's not rational, it's not integer, it's a number such that if we square it, we get 2. I repeat myself, 2 to the 1/2 is a number that if we square it, we get 2. From this law, we came up to this beautiful kind of understanding in a sense, and to this kind of observation. Now, we come back to this. Well, I have written that one for you. Now let me go to the next one. Next one is going to be a little bit long, I suppose. Let's see, hopefully it does not interfere with Now, I've written here, since 2 to the 1/2 is the solution for x squared minus 2 equal to 0, which means if you replace x by 2 to the 1/2, then 2 to the 1/2 times 2 is what? Is 2, and 2 minus 2 equal to 0. And whatever makes this one is 0 is called root. It's called root of that equation. Root. And this root, the letter R as a root, was the mathematician, I forgot his name, that he first write root of 2 in a sense, because the answer of that is root 2, so he write this notation, R2. Do you follow me? So then this symbol R adapted to represent root. And that's what the symbol of radical comes from. Do you follow me? I don't know if I have it in, yeah, I do in fact, that's fantastic. I have it in a larger, I have written so that you can see that. So let me say it, why not? So 2 radical 2, I have said it here. Yeah, please take a note if you wish, so that it may prove to be very beneficial. Okay, let me put this one up. This is interesting. You know the word root, R-O-O-T. Then the first letter of the root is R. You see that, how R is written? And if you write R kind of a little bit fast and quick, it looks like radical. You see that? And then the mathematician was writing this one, I forgot his name, and writing 2 in there, saying that is the root of 2 is what? Is the solution for x squared minus 2 equal to 0. There is a historical background for that. Then one mathematician said something very nice that I also agree with that. He said that I wish this notation was not invented. In other words, we would have lived with 2 to the m to the n is equal to the m times n. Because it does all the job for us anyhow. Why do we invent a new notation? But later on we noticed that this notation of a square root of 2 or nth root of 2 or what have you has some benefit also. But anyhow, that is some historical background. Now, what will be 2 to the 1/3 then? How do we explain 2 to the 1/3, 2 to the 1/4, 2 to the 1/5, 2 to the 2/3, a to the let's say x to the m over n? How do we do that? And that we come to this because that the notation of radical was invented. We have to live with it, so we try to make the best out of it. And we come to this that 2 to the 1/3 is equal to we write the 3 here and 2 here, and we put a name for them. This is called the index, and it's always 2 or more, and is integer 2, 3, 4, 5, and so on. And this is called radicand, and the whole entire of this is called radical. Now, what this have to do with a square root of x squared to be absolute value of x has quite a lot. He's giving you the background that you need so that you know what was the motive of defining a square root of x squared to be equal to absolute value of x. A square root of x squared is not equal to x. Okay, then I thank you for watching, and in the next video we go and not wrap it off in a sense, the fourth one when we will wrap it up. In the next video we will go and see the motive of defining a square root of x squared to be equal absolute value of x, and we also discuss about the principal square root. Okay, then I thank you for watching. Please take care of yourself and stay safe, and have a great day. So long.